Section 4.3, Establishing Causation. Following are some examples of observed association between X and Y. We're going to go through each of these 6, and we're going to talk about causation, common response, and confounding between variables. Relationship number 1. There's an association between a mother's body mass index and her daughter's body mass index. The amount of artificial sweetener saccharin in a rat's diet, and the count of tumors on the rat's bladder. Number 3, a high school senior's SAT score and the student's first year college grade point average. Number 4, monthly flow of money into stock and mutual funds, monthly rate of return for the stock market. Number 5, whether a person regularly attends religious services and how long the person lives. And 6, the number of years of education a worker has compared to the worker's income. So those are 6 different situations in which there is an association between the 2 variables as presented. However, is that association a causation relationship, a common response relationship, or a confounding relationship? And this slide gives a very good detailed description of what each of these 3 things are. Letter A, causation. Variable X and Y show strong associations. The associations are given by the dotted lines. So we know in each of these 3, X and Y are associated in all 3 of these situations. That's what's represented by the dotted line. This association may be the result of any of several causal relationships, which is the solid arrow. In A, represents causation. Changes in X causes changes in Y. That's shown by this direct line right here. So not only are they associated, but it is determined that X causes the changes that we are measuring in Y. Common response. Changes in both X and Y are caused by changes in a lurking variable Z. So we know that X is associated with Y, represented by the dotted line, but this third variable Z is actually causing X and Y, the changes in each of those. And C, confounding. The effect, if any, on X of X on Y is confounded with the effect of a lurking variable. So now we have a third lurking variable still, but now we don't know whether or not it is X that is causing the changes in Y, or whether it is the third variable Z that is causing the changes in Y. Each one of these 6 relationships that we talked about here, 2 are examples of causation, 2 are examples of common response, and 2 are examples of confounding. So let's look at each one of those. First 2 items, items 1 and 2, are examples of direct causation. Thinking about these examples, however, shows that causation is not necessarily a simple idea. The first one, which said that a mother's body mass index is associated with her daughter's body mass index. A study of Mexican-American girls aged 9 to 12 years recorded body mass index, a measure of weight relative to height for both girls and their mothers. People with a high BMI are overweight or obese. The study also measured hours of television, minutes of physical activity, and intake of several kinds of food. The strongest correlation R was between the BMI of daughters and the BMI of their mothers. Remember, R is measuring the correlation of the straight line or linear relationship between the 2 variables, BMI of daughters and BMI of their mothers. Body type is in part determined by heredity. Daughters inherit half of their genes from their mothers. As a result, there is a direct causal link between the BMI of mothers and daughters. Yet the mothers' BMIs explain only 25.6%, that's R squared, of the variation of the daughters' BMIs. Other factors such as diet and exercise also influence BMI. Even when direct causation is present, it is rarely a complete explanation of an association between 2 variables. So out of BMI, number of hours watching television, minutes of physical activity, and intakes of food, the strongest correlation was between the BMI, but again, that correlation only explains 25.6% of the variation of the daughter's BMIs. So we see that there is some causation there, but it is not a complete picture of what's going on. Number two, second one was the amount of artificial sweetener, saccharin in a rat's diet, and the count of tumors on the rat's bladder. The best evidence for causation comes from experiments that actually change X while holding all other factors fixed. In next chapter, we're going to talk about this. If you want to establish causation, the best way to establish causation is in an experimental setting where you can control some of the other factors or as many of the other factors or lurking variables that may exist. If Y changes, we have a good reason to think then that X caused the change in Y. Experiments show conclusively that large amounts of saccharin in the diet causes bladder tumors in rats. Should we avoid saccharin then as a replacement for sugar in foods? Well, rats are not people, and although we can't experiment with people, studies of people who do consume different amounts of saccharin show little association between saccharin and bladder tumors. So even well-established causal relationships may not generalize to other settings. So while we know from the experiment that in fact there is a direct causation of amount of saccharin and the amount of tumors on the bladder of rats, we can't necessarily take that information then and apply it to humans because humans react differently to saccharin than what rats do. Common response. Third and fourth items in that list that we talked about illustrate how common response can create an association. Third one was the relationship or association between a high school senior's SAT score and their first year college GPA. Students who are smart and who have learned a lot tend to have both high SAT scores and high college scores. The positive correlation is explained by the common response to students' ability and knowledge. So in other words, if the student is smart, that is going to affect not only their SAT score, but also their GPA in college. So we have that third lurking variable there of the intelligence of the student that is directly causing an increase in SAT scores and an increase in GPA. Number four, there's a strong positive correlation between how much money individuals add to mutual funds each month and how well the stock market does the same month. Is the new money driving the market up? The correlation may be explained in part by common response to underlying investor sentiment. When optimism reigns, individuals send money to funds, and the large institutions also invest more. The institutions would drive up prices even if individuals did nothing. In addition, what causation there is may operate in the other direction. When the market is doing well, individuals rush to add money to their mutual funds. So this time, consumer sentiment, whether they feel good about the way the economy is going to determine whether or not they invest money. And companies, if they think the economy is doing well, that is going to directly affect whether or not they invest in improving their companies, hiring workers, things like that. So we have the consumer sentiment as our lurking variable here that really causes both of these other two variables to happen. Confounding is the third one. Confounding, two variables are confounded when their effects on a response variable cannot be distinguished from each other. The confounded variables may be either explanatory variables or lurking variables. The last two associations are explained in part by confounding. So the fifth one was whether a person attends religious services and how long the person lives. Many studies have found that people who are active in their religion live longer than non-religious people. But people who attend church or mosque or synagogue also take better care of themselves than non-attenders. They are less likely to smoke, more likely to exercise, and less likely to be overweight. The effects of these good habits are confounded with the direct effects of attending the religious services. So there is an association that people who attend some type of church on a regular basis do live longer, but it's also a known fact that people who attend religious services on a regular basis are also less likely to smoke, more likely to exercise, less likely to be overweight. Therefore, we don't know if it's one of those three variables or the fact that they are attending a religious service that is leading to them living longer than people who do not attend the religious services. So all of those variables are confounded with one another because we're not sure which one is causing the person to live longer. Number 6 was the number of years of education a worker has and the worker's income. It is likely that more education is a cause of higher income. However, highly paid professionals require advanced education. Confounding is also present here. People who have high ability and come from prosperous homes are more likely to get many years of education than people who are less able or poorer. Of course, people who start out able and rich are more likely to have higher earnings without much education. We can't say how much of the higher income of well-educated people is actually caused by their education. So was it their socioeconomic status before they even entered school? Okay, parents are rich, parents are poor. Is it that's affecting their wages later on in life, or is it the amount of education that they're receiving? Again, those two variables are confounding because we don't know which one of those two is causing the increase in income. Establishing causation. Let's answer this question in general terms. What are the criteria for establishing causation when we cannot do an experiment? Again, an experiment is the best way to establish causation because we can limit the effect of lurking variables by exhibiting control in our experiment. If the association is strong, that would be one way. The association between smoking and lung cancer is very strong. Association is consistent. Many studies of different kinds of people in many countries link smoking to lung cancer. That reduces the chance that a lurking variable specific to one group or one study would explain the association. Larger values of the response variable are associated with stronger responses. People who smoke more or smoke over a longer period of time tend to get lung cancer more often. People who stop smoking reduce their risk. The alleged cause precedes the effect in time. Lung cancer develops after years of smoking. The number of men dying of lung cancer rose as smoking became more common, with a lag of about 30 years. Lung cancer kills more men than any other form of cancer. Lung cancer was rare among women until women began to smoke. Lung cancer in women rose along with smoking, again with a lag of about 30 years, and now has passed breast cancer as the leading cause of cancer death among women. The alleged cause is plausible. Experiments with animals show that tars from cigarette smoking do cause cancer. So we have 5 different things here, okay, why we can't directly do an experiment where we force people to smoke to see whether they are going to get lung cancer or not. Each of these 5 things show that there is a strong causal relationship between smoking and lung cancer. The association is strong. The association is consistent. Larger values, or the more people smoke or the longer period of time people smoke, the more likely they are to get lung cancer. The alleged cause precedes the effect in time. We know that there's a lag time of about 30 years in lung cancer, and the cause is plausible because we can show the same thing in an experimental setting with animals. State whether the relationship between the two variables involves causation, common response, or confounding. Identify the possible lurking variables and answer any of the other questions that are asked. So here, do artificial sweeteners cause weight gain? People who use artificial sweeteners in place of sugar tend to be heavier than people who use sugar. Does this mean that artificial sweeteners cause weight gain? Give a more plausible explanation. Okay, in this case, this is a situation in which we have causation, but in reverse. Meaning that people who use artificial sweeteners tend to already be overweight. And may be trying to lose weight. serious study once found that people with 2 cars live longer than people who own only 1 car. Owning 3 cars is even better, and so on. This is a substantial positive correlation between the number of cars, or there is a substantial positive correlation between the number of cars and the length of life. What lurking variables might explain the association between the number of cars owned and lifespan? Well, this is an example of common response. Remember, common response means that we can identify one lurking variable that causes both an increase in the number of cars a person owns and the length of life that they are going to live. In this case, the lurking variable is the wealth of a person. Allows them to own more cars. And afford better health care and the means to live a healthier lifestyle. So that third variable of wealth is causing each of those to happen. That is why it is common response. Data show that men who are married and also divorced or widowed men earn quite a bit more than men of the same age who have never been married. This does not mean that a man can raise his income by getting married, because men who have never been married are different from married men in many ways other than marital status. Suggests several lurking variables that might help explain the association between marital status and income. Okay, first of all, this would be an example again, or I'm sorry, this time of confounding, meaning that there are several variables which could be affecting the wealth of the man. Okay, what are some other lurking variables that might explain the association between marital status and income? Well, one could be that women marry wealthier men. Some people would call them gold diggers. It's supposed to be funny. That's a joke. Do not get offended by that. Second thing, married men and single men have different values. Single men may not want a family. They may not want a wife. They may be more focused on their careers and earning money for themselves, while married men may want children and so on, and therefore there are different values as far as money, family, things like that. Last one. People who do well tend to feel good about themselves. Perhaps helping people feel good about themselves will help them do better in school and life. Raising self-esteem became, for a time, a goal in many schools. California even created a state commission to advance the cause. Can you think of an explanation for the association between high self-esteem and good high school performance other than self-esteem causes better work in schools? Again, this is a situation that could be causation, but in reverse. Meaning that doing well in school raises self-esteem. And there are there's a summary of what we've talked about. If you have questions, make sure you're getting in to get extra help. Make sure, again, you know the boldface words. Make sure you know the difference between common response, confounding, causation, and how you can establish what may be affecting the association between two variables out of those three.